Oh, very good. Okay. All right. Well, thanks everyone. And thank you to the organizers of the forum. I'm excited to be here and it's great to see everybody. I want to talk today about partnerships, which I think are absolutely key to making the EPP MSI program successful. And in particular, I want to talk about how we started our partnership program. So let me first start off by acknowledging my co-authors here who all contributed not just to the presentation, but to making our partnership successful. Being part of NOAA, we're full of acronyms: PSL, Physical Sciences Laboratory. I think most of you know CESSRST, but Center for Earth System Science Remote Sensing Technology, which is a mouthful, so if it's okay, I'll just say CESSRST from here on out. And of course, City College of New York, which I'll refer to as CUNY. And so let me go ahead and first say a little bit about myself. I work at the Physical Sciences Lab. I'm a hydrometeorologist, which means I kind of deal on both sides of the hydrology and the meteorology as well. I actually started out in geology and ended up going into atmospheric science, thinking because I was a geologist, I was going to go into paleoclimate, right? Because that's what a geologist would study. But I ended up in radar meteorology just to show how opportunities can present themselves. And I took that opportunity and it's been great. So now I've kind of come full circle back into the world of hydrology and meteorology itself through the geoscience training. So there you have it. And if I need to point that here, that worked good. So on the partnership between our lab and CESSRST, this all started back at the last biennial in Washington, D.C. in March 2018. The in-person one, I remember that vividly. I don't know if anybody else was there present for that one, but there was a snowstorm in DC in March. And snow in DC is a big deal because they don't get it very often. When they do, it's usually a big problem. So, but it was a terrific opportunity. Our lab went just to better understand what the landscape was like for working with cooperative science centers. And so that was an opportunity to meet Shakila and others from CESSRST and talk about how we might work together in the future. And we planned out a workshop in August of that year. It was a 3-day workshop. We brought together some of our PSL staff, some of CESSRST faculty from the consortium of universities, which I'll mention in a minute, and students. And we talked about areas where we could collaborate and not only on internships, but brown bag seminars, possibly exchanges of faculty with the lab and so on. And importantly, we identified 3 main areas. Okay, just a note to self, the pointer doesn't work. 3 main areas of collaboration: flood forecasting, snow processes, and drought. And as you'll see, we've made a lot of progress in all 3 of those areas.
Maybe you make a slideshow first, then we'll work.
Sorry?
You have a slideshow, full screen.
Oh, thank you. Let's see. Is that? I didn't realize it wasn't on the. Okay, there we go. All right. Okay, so that was the partnership beginnings.
Good afternoon. I'm Vitaly Kolotowski,
and
PhD candidate from University of Maryland. And this is joint work with my advisor, Dr. Lian, and my co-advisor, Dr. Gilliland. And this talk is a follow-up on a paper we published last year, where we introduced general special temporal threshold clustering method, which is very useful for identifying extreme events pattern in the spatial temporal domain. So this talk will discuss some of the application of this method to the trend analysis. And this is still work in progress, but I do have some examples to show and discuss.
Can we make a post so we can mute some people?
Wanted to look for. Looks like it's gone.
Yeah, it looks like.
It's gone.
Okay, all right, it disappeared. Good for us. All right.
Can you move that little box?
Yeah, I can learn it on the go here. All right.
It's gone.
Yeah, something's, let me see if I can get screen sharing. Dock to bottom, how about that? Is that better? Yeah, okay. All right. So I wanted to, before we get into the students themselves, talk about their projects, I just wanted to mention some of the goals in water resources research. For the physical sciences lab, we do weather, water, climate research for water availability and for extremes. And that's really where we connect with NOAA's broader mission. We heard it this morning from Dr. Spinrad, science, service, and stewardship, predicting weather and climate, understanding climate change, sharing that knowledge with users, and of course, ecosystem services, oceans and coasts. So it's a very broad piece. Our lab, this is where most of our focus is. And
So the outline
CESSRST,
of my talk is as follows. First, I quickly introduce STTC, which is short for the special temporal threshold clustering method. I discuss raw moments that are very useful in understanding the pattern changed, how the pattern changed, whether it's moved, dissipated, and so on. All the work will be done in multi-resolution. All the work will be done in transform space, would be a wavelet space. Would be all the work here would be done in a wavelet space where we perform multi-resolution analysis to isolate pattern by scale to reduce the uncertainty and the noise. And those patterns can be recombined later in the original pattern, discuss applications, and come up with the conclusions, and wrap up with the conclusions.
do we get it? Should I try it again? I don't know. Let's see if I. Well, it's quiet, but this happened before. It got quiet. So I don't know what's going on. Okay, so I'll just try it. All right. Okay, let's go ahead and continue. I apologize, everyone. Hopefully we're in better shape now. I was talking about physical sciences lab, and I just wanted to also mention the complementary nature with CESSRST in terms of the consortium of universities. In addition to City College New York, we have Hampton, San Diego State, University of Maryland, Baltimore County, University of Puerto Rico, Mayagüez, and University of Texas, El Paso. And the focus areas, there are 3 focus areas: coastal resilience, atmospheric hazards, and the important one for us, which you cannot see, I'm going to have to shift this again, is water prediction and ecosystem services. I should say this turned out to be a really fortuitous partnership because of the fact that CESSRST places a big focus on observations and models in order to get a more holistic understanding of Earth system science. And of course, that's very complementary to what we're doing in our lab. So worked out well overall. We're having a time. Let's see. All right. All right. So let me talk a little bit about some of the students and the internships that we've had. I'll be talking about the NERTO we heard this morning, the NOAA Experiential Training and Research Opportunities, and as well as undergraduate opportunities as well. So our first NERTO in our lab was Carlos Gonzalez here, who from the University of Puerto Rico, Mayagüez, who has since graduated in electrical engineering. Carlos was working on developing a model to simulate brightness temperatures from a body of water with specified salinity and temperature. Now, why was that important? That's important because NOAA is trying to develop a UAV that's an uncrewed aircraft capability to monitor soil moisture and salinity of different water bodies, including the ocean. So that would be a real game changer for us in terms of our ability to get high resolution data when and where we need it the most. So that's what Carlos was working on. Gary Wick was his mentor. He was at our lab in the spring of 2018. And then about the same time, well, a little bit later, also from the University of Puerto Rico, Mayagüez, Jean Valle, civil engineering department. He was a master's student. And Jean was working on an evaluation of the framework for the National Water Model, which is called WRF Hydro. And he was looking at its application in Puerto Rico. As many of you know, Puerto Rico is an area that's very mountainous. So complex terrain, trying to forecast rainfall, let alone the stream flow that comes from that rainfall, is a big, big challenge. So Jean worked with Kelly Mahoney in our group at the lab, and he worked on looking at the effects of using what we would call different forcing. So if you put like precipitation that comes from a global model's got a huge footprint. It's like 13 kilometers. So you try putting that on complex terrain, and it's not going to do a very good job at capturing the rainfall gradients. So Jean was able to document that for selected cases and selected watersheds that are shown up at the top there. And then he used high resolution models. He used the WRF model, and he also used what was the high resolution rapid refresh. That's that's NOAA's kind of flagship regional model. At the time, they had a Caribbean nest that had Puerto Rico within it. And so he used that to look at the effect of high resolution modeling. And yes, in fact, it made a huge difference in terms of stream flow. So shortly after Jean left, Jean finished his master's degree and has gone on to private industry. Adrian Pena came to us from CUNY. Adrian was working with also an evaluation of that Kerr model, high resolution rapid refresh, using a network of observations that CESSRST have placed in, or I should say CUNY have placed around New York City. These are mesonet stations that measure things like temperature and precipitation and winds and so forth. So as you can imagine, trying to do forecasts in the urban environment has its own set of challenges. You've got lots of buildings, you've got an urban heat island effect and so on. So Adrian's challenge was how to understand how a model that even though it's high resolution, it's still 3 kilometers on the side. How that footprint compares to a point observation. How do you make that comparison? So what's the uncertainty look like and how do you deal with that? That's a big issue for the HER development team because they're trying to improve their characterization of the urban environment, and New York City was a perfect test bed for that. And I'll be talking a little bit about how the next step in using those micronet observations is we're working with those as well. So Adrian went on to get his master's and he has since graduated. Okay, those were the people I talked about up till now, all were doing NERTOs. Kofi here, Apegnadero, was an undergraduate student and an undergraduate scholar. And he was also our first student who came to us virtually after COVID got going in July of 2020. COVID did a virtual, Kofi did a virtual internship with us, and he worked with Roger Puardi, our senior scientist, and myself. And Kofi was looking at what we call whiplash events. What's a whiplash event? Or a flip-flop event. Well, if any of you are familiar with the weather in California, you know, they go from extreme to extreme. They go from drought to flood to drought to flood. And this year is a perfect example. October, record flooding, just boatloads of snow. October, saving the water year, right? December, same thing. Trouble is, it stopped snowing, it stopped raining after December, and now they're in a terrible drought again. So back and forth. And Kofi did a very impressive literature review to try and understand not only what the history of these flip-flop events are, but what that's going to look like in the future for California. And this gets back to NOAA's mission about sharing our information with stakeholders. We do a lot of work with California water managers. So this kind of information is really, really important for them to understand what this looks like. And you can see in there, you have, in this figure, you have a dark line that sort of indicates the mean, and then you have the envelope of uncertainty around that. So being able to communicate that uncertainty is critical for water managers to make decisions about how they're going to allocate water resources. Okay, and then our next virtual student was a NERTO who is with us here, Angela Shapit. Angela is a PhD student at CUNY, and she started her NERTO back in March of 2020. Is that right? Did I get that right? Okay. So, but this is really important. Angela's still working with us. She's integrated into our group. She's part of the team. And this is one of the lessons that we really learned, I think, in a very positive way with Angela, that aligning your thesis, your project with your thesis is a win-win situation for everybody. It's helping Angela out. It's helping us out because she's addressing a really, really important topic for us. This gets back to the national water model. But Angela's looking at snow processes. She's trying to understand how the land model that's embedded within the water model, how it deals with snow. So she's been using CUNY observations near Caribou, Maine, to test how the land model responds to those direct observations, as well as from different forcing. So back to those precipitation inputs and solar radiation and so on. And then she's expanded that to the watershed scale to try and understand how that land model impacts stream flow response. And now she's moving on to a machine learning aspect, looking in California watersheds to see if she can improve forecast accuracy using artificial intelligence. Okay, another student that has been with us for a while, 2 minutes. Wow. Okay, Caroline, I'll say very quickly, Caroline just finished her master's. She's also a geology major. She's now working as a graduate assistant for a NOAA a NASA climate change program. She also was doing national water model work, looking at the impact of downscaled medium range forces from the NOAA's medium range model, the Global Ensemble Forecast System. And we have a student who just started with us, Sienna Dante. I don't know if Sienna's here, but she is here. Hi, Sienna. So Sienna is doing a hybrid NERTO. She's actually coming next week to Boulder, and she's working with two of our colleagues in PSL looking at crop yields as a function of climate variability and how well we might be able to use signals like ENSO and the MJO and so forth to be able to predict what crop yields are like. And then we have another student coming with us this summer, Jake, who's also a geology major from CUNY, who is building on what Adrian did with the micronet observations in New York City, and we'll be applying them to a field campaign we have in the Upper Colorado Basin called SPLASH, the study of precipitation, lower atmosphere, and surface hydrology and surface for hydrology. That funny looking thing there is a surface radiation measurement. It was up, our instrument, it was up in the Arctic for a year and a half on floating ice. These things are very sturdy. And Jake will be applying his knowledge to help us interpret those observations. So I talked a little bit about NOAA's mission here, science, service, and stewardship, but I just wanted to reemphasize that these NERTO and undergraduate opportunities are really focused on that particular aspect of the mission. And for us, that's all about improving hydrologic and atmospheric prediction, and a range of timescales, literally from hours to subseasonal to seasonal S2S. And again, how we communicate with stakeholders, that's really critical for what we do in NOAA, is sharing our information in a way that can be actionable. Very quickly, let me just say, we've learned a little bit through these internships about how to be successful here. And so a few thoughts about that. First, let me say we've benefited greatly from the NERTO experience. Having the students working with us has been positive for the students as well as for our lab. And just in terms of thoughts for how to do this in a way that really is win-win, it really is helpful to develop a detailed work plan. Make the expectations realistic. If for a NERTO, you've got 12 weeks and you're going to have to spend time learning your systems and so on. So it's really key to be realistic about what you're doing. You need to get the students as much as possible engaged in the day-to-day activities. Of course, that's much easier in a in-person as opposed to a virtual. The alignment, as I mentioned, of the internship with the thesis project really is beneficial. And lastly, I'll just say, we're really hoping that the partnership is going to continue to grow. We anticipate more student internships, but importantly, we're looking for opportunities to bring people on board long-term, to bring people in as federal employees, and scientific exchanges I mentioned. We'd like to get more and more students engaged with PSL field projects. I talked about the Arctic, the SPLASH campaign, also in the tropics. We do a lot of work around the world, and it's a great opportunity for students to get involved. And then I'll just, the last thing I'll mention is now that we're coming back to the office later this month, NOAA's going back into their buildings. We're hoping to have a retreat to talk about what we've learned over the last few years since that 2018 workshop and what we can do in the future to plan ahead for future collaboration. So with that, I apologize, it went a little long. We had a lot of interruptions to get going. Anyway, thank you very much.
All right, thank you.
presentation. We have time for 2 questions. Anybody has a question or comment?
Just wanted to
Yes.
say thank you, Rob, for allowing us to come to your lab and really students benefited from your experience, your team experience.
Yeah, well, likewise, Brenda, it's been great.
All right, very good. You had a question?
Yeah, how does PSL interface with the others at the lab like PSL?
Yeah, we just talking to Danae about that. So we have a lot of interaction. Danae's team does a lot of that. I talked about the HER model. So GSL, they're the HER model developers. So we work very closely with them on evaluating the model. From our perspective, it's trying to understand the physical processes. So we want to say, hey, Danae, your model got the right answer for the right reason. It didn't get lucky here. It has the right physical processes. So we do a lot of work, not only with the HER model, but also with visualization tools. So we do try and work among the labs as closely as we can.
Okay, here, one last question.
Rob, can you emphasize the role of the early engagement in the process and how effective is it and how successful is it?
Yeah, it's really, really important to get going. And I think Sienna can testify to that. I forget when we began our conversations, but trying to identify the right mentor to develop the correct project that's going to benefit not only the lab, but the student themselves, and coming together to come up with a detailed work plan. It's realistic. And again, it's a win-win for everybody in terms of what they're going to get out of it and what the lab, in this case, our lab is going to get out of it as well. Absolutely critical. Thank you.
One more point I want to add to the early engagement is after this meeting in 2018, we were invited to give an OAR nurture workshop, which really expanded our internship opportunities with other OAR labs in ARNL, Miami, and also DFDL and Princeton. So I think what is important in terms of early engagement is to really come together at the beginning and phase out the planning of the projects. We're hoping to do the same with GML and GSL labs as well. It is really a good best practice to bring the group of people together, like a think tank, create that think tank early on so that a lot of projects can fall in place accurately.
So once you build that the right foundation, it goes from there.
Yes.
Okay, very good. Thank you very much, Rob. Our next speaker is the Mark